Welcome back. This is Dr. Oscar Rodriguez with Electronic Engineering Technology Fundamentals. And so far, we have studied part one of this course. Four lectures were covered on part one, all dealing with safety and including troubleshooting procedures. And now we are going to start the second part of the five parts that this course consists of, which is the current circuit and devices. All right, now later on we're going to be doing alternating current, digital circuits, and electronic semiconductors. So let's go directly over to the session of today, the lecture of today, which deals with sources of electrical energy. And this is not an exhaustive study, but just an overview. Remember, this course is a survey of electronics circuit fundamentals. And so the objective of today's lecture is to be able to identify common sources of electrical power. And it's true, there's more to be said. We're going to just concentrate on a few of these electrical power sources. So electrical energy can be harvested from various sources. Some of the common sources of electrical power include, but not limited to, chemical sources such as the batteries, natural sources such as wind and water, solar and heat. In the case of natural sources, they need to be converted via a generator. In the case of wind and water, you also have PV or photovoltaic, which uses radiation. And then you have thermal sources that also require the conversion of devices so that we can use that energy generated by the heat. All right? So let's go over each one of them in detail. Chemical sources such as the batteries. And this could be a small battery that you use to power your shaving machine, or it could be a small battery that you use to power a little LED, or it could be a larger battery that you use to power up your car, or something like that. In essence, there's a lot of technology behind batteries, but we are going to only say that batteries rely on chemical reaction to produce the voltage. Whether that's a wet battery or a dry battery, the technology in batteries is growing and will continue to grow. So we could actually have a whole course just on batteries. But the basic concept I want you to get here is that batteries become a great source of electrical power. Now, we have a few troubles with batteries, and that is that they have limited capability and they have limited life. And so that's one problem with batteries, but they do great storage devices and they can be used as sources of energy. All right. Now we also have natural sources as wind, water, solar, and heat. Notice that the U.S. consumption energy consumption chart deals just not with the one source that we're mentioning here, but there's other sources. But in our case, we're limiting ourselves to study electrical sources, and that's the reason why we have solar, wind, geothermal, even, which is another form of saving or creating energy from the earth or the ground. And we also have hydropower, which is another means of generating energy. One more is biomass. It's one form that is also popular being used today. As a matter of fact, 2.9 of the energy consumption in the U.S. is based on biomass. All right, so those are important notations regarding natural, what you would call natural energy sources. All right. Now, number three, in the case of the natural sources, they need to be converted via a generator. In the case of wind and water, you take the wind that is blowing, and then you use the blades of a generator that will convert that wind blowing effect into energy. Whether that's AC or DC, it's up to you, but it's one form. In the case of the flow of water, which what we call hydropower, you also need a generator. You need a generator that will harvest the flow or the power of the water, so you can convert that water energy into usable electrical energy. And once again, that could be DC or AC. Now, there's a few processes that take place when we're doing this wind and water energy conversion. And that is, there's a process what we call rectification, which is converting AC into DC. All right, and typically that's what you do with this type of two forms of energy. You also could do conversion. In other words, if you had DC, you can convert that to AC via a converter. With the whole idea of maintaining a constant voltage. That's what you want with this, all right? So that's the conversion factor. Now, in the case of the PV or photovoltaic, that's the case of sun radiation. Essentially, what you have is a solar photovoltaic that converts solar energy, not by electromagnetic induction, not by regulation, but by we call photovoltaic action. All right, and essentially, there's a lot of chemistry and physics behind it, but in essence, what happens is that the radiation of the sun hitting the cells creates the displacement of electrons and protons, and as a consequence of that, difference of potential is created or voltage. And so you either accumulate or store the energy into a battery system. You use a battery charger or controller, and then you could use the direct voltage coming out of that solar photovoltaic, or you could convert that to make it useful for other purposes such as AC. But that's the whole basic purpose of solar photovoltaic. Finally, we have a thermal converting system in which the heat of the sun, not just the radiation, but the heat of the sun is harvested so that you can change the temperature of liquid, in this case water, or you could actually blow that hot air and drive it over to a place where you can use it. This is what we call thermal conversion, which is another form of harvesting energy from the sun. In addition to that, there could be other forms of thermal conversion too, but we're going to limit it here to the basics, all right? The basics. So we can actually say that chemical sources such as batteries rely heavily on chemical reaction to produce a voltage. You also have the fact that there's natural sources such as wind and water, solar and heat. And these are different kinds of natural ways of harvesting energy. We also mentioned that in the case of natural sources, they need to be converted via a generator. In the case of wind and water, the wind and the water has to be harvested via a generator. And in that process, we could have a converting system to take that AC and put it into DC, or vice versa, a converting system that will take the DC and make it AC, with the idea of maintaining a constant voltage to provide whatever it is that we need to provide. Finally, we have a solar photovoltaic system that uses the sun radiation, and in this case, the photovoltaic action is what makes this possible. Harvest the radiation of the sun, and by chemical physical reaction produces a voltage that we now can use to store it or to convert it to AC voltage. And finally, we talk about thermal converting devices. Example of that is a boiler heating water to produce steam. That's another form of thermal conversion of energy or harvesting of energy, all right? So that's what we have studied so far today. And once again, this is sources of electrical energy. A very simple lecture, but something important before we dive into a little more regarding this circuit. So once again, Dr. Oscar Rodriguez with Electronics Engineering Technology Fundamentals. I will be seeing you in our next lecture. This being lecture number 5 on sources of electrical energy. Good luck on taking your quiz. I know you're smart. Review this information and do well. See you next time.